right, now I'm going to continue on and I'm going to play devil's advocate here. So we had this original problem here. Let me go back to our original statement. Oops. We wanted to find two z values that separate the middle from the upper and lower 0.5%. Now I'm going to play the devil's advocate and I'm going to say, okay, well, what if it wasn't a z-score, but instead, what if it was a normally distributed random variable with a mean of 25 and a standard deviation of 2? Well, if that's the case, we're not going to do anything differently than what we did at first. The first thing that we had just done was in the last video where we found the values that put the 0.005 over here, so 0.05% or 0.5%, right? So 0.005 there and 0.005 up here. And we did that with a z-table, or I showed you how to do it with the t-table, and I showed you how to do it with your TI calculator. So let's just go with the TI calculator one, where we said this was the inverse normal of 0.005. And this, of course, gave us to 2 decimal points, negative 2.58. Now, remember that this could have also been an inverse normal of 995, which is the complement of this, right? 1 minus 0.005, which is going to give you that 0.995, and this one will give you a positive 2.58. So at any rate, we get our two z-scores, a negative over here and a positive over here. Now, if we want to know the values that are in this normal distribution that has this mean and this standard deviation, we have to unstandardize it. So now we're going to do this unstandardizing part. Remember that the z, which is our x, minus our mean divided by standard deviation, is just a transformation. So we're going to untransform this. So this is unstandardizing. And we're just going to plug in to this z transformation here, and then we're going to solve for the x's. So as I plug in here, I know that my z is a negative 2.58, and that's equal to whatever my x is going to be, minus my mean, which is 25, and divided by my standard deviation, which is 2. Now, it doesn't matter for this whether this is a plus or a minus, right? It's going to work out exactly the same way. Just one time I'll use a plus and one time I'll use a minus. So I'm just going to solve it one time for you. So what this does is now it goes to 2 times that plus value or that minus value, and that's 2.58, and that's equal to my x minus my 25. Now, one last thing is I need to get this away from it so I know what the x values are. And so now I'm going to add this 25 to both sides. Remember here, all I did was multiply both sides by 2. I'm just doing algebra, right? So now I'm going to have my x is equal to 25, and then it'll be plus, and then it's 2, and it's either times a positive or a negative 2.58. Now what I need to do here is I need to find out what this value is, because whether it's positive or negative really doesn't matter, right? So let's just do that. So we have 2.58, and then we're multiplying that by 2, and that's equal to 5/16. So we have 5/16 here, so this is equal to 25, And because it's plus or minus, I'm just going to move that plus or minus over here, right? Plus or minus, and that's 5.16. And now I know that my x values are either x is equal to 25 minus 5.16, or my x values are 25 plus 5.16. So if I just do a little math on this, and I'm just going to do this on my calculator that's not on my screen, but I think you'll know what I'm doing here. So that minus 1 gives me 19 point, and then 84. And this one will give me 30.16, no calculator needed. And those are my two values. So this now is taking the place of this. So when my mean here is at 25, then this z value, negative 258, is actually 19.84. And this z value up here is actually 30.16. And this value here is representing this 2.58 standard deviations above this mean 25. And this 19.84 is representing this 2.58 standard deviations below this mean 25. And that's what we do if we have a non-standard normal. Now I'm going to go on and I'm going to show you what happens when we have instead of a z value and instead of just a single random variable, what if we have an average instead? So what if the value is an average instead when we have a sample of 100, so we have n equals 100, and the mean is 15 this time and the standard deviation is 8. Well, we're still going to find those z-scores just exactly the same way that we did before. So we have our z's, and these are going to be equal to a plus or a minus 2.58. If you have any questions, turn the page back. So if you have any questions, go back and review. But past that, we're just going to move forward here. So once we have those z's, now we're going to unstandardize. But this time around, our unstandardizing, we're going to use our mean of 15, and we're going to use the standard error because this is the central limit theorem because we have this average. So we are going to use a standard error of 8 divided by the square root of 100. And this is going to give us 0.8 because this is 8 divided by 10, and 8 divided by 10 gives you 0.8. So that's going to be our standard error. So this time, what we're going to have is our z of plus or minus 2.58, and then that's equal to, and this time because it's an average, we call that an x bar, minus our mean, which is 15, and then divided by our standard error of 0.8. Now, the solving of this goes exactly the same way every single time, so I'm going to also say from here, see solve before. And then from that, what we're going to do is we're going to go ahead and we're going to see that what we get out of here is that our x bars, our averages, right, are going to be equal to our mean 15 plus or minus our critical value, that's that z-score, 2.58, and then times my standard error, 0.8. So now I can see that this is 15 plus or minus this 2.58, so I'm just going to do it on my calculator, 2.58 multiplied by 0.8, and that this time is going to give me 2.064. And then I can have my x bar on the left-hand side being 15 minus that 2.064, which is 1, 2, 12, 936, or it is x bar is going to be 17.064. And so this time, oops, that didn't turn out very well. Let me erase that so you could see that as a 4. This time around, these are my two left and right values. And these are what put our population mean, and let me show you a quick picture of this, our population mean in between here. So now what these are showing me is this is showing me that I have a 12.936 up to a 17.067 for these values that surround the mean of these of this thing. So that is 2.58 standard deviations below this 15, and this is 2.58 standard deviations above it. So hopefully that explains how you can use this inverse normal distribution very well. Now the next thing I'm going to show in another video is how to relate this to a confidence interval.